Welcome back, everybody. Mr. Antonucci here, and in this video, we're going to go over some multiple choice and free response questions from AP Calc Unit 8. We're going to look at questions that involve using Desmos, as well as those where Desmos is not going to be permitted. So let's go ahead and jump in. So we'll start off with this free response question: a particle moving along the x-axis so that its velocity at any time t from 0 to 6 is given by the differential function v, whose graph is shown above. The velocity is 0 at t equals 0, 3, and 5, and the graph has horizontal tangents at t equals 1 and 4. The areas of the regions bounded by the t-axis in the graph of v on the intervals 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2, respectively. At time t equals 0, the particle is at x equals negative 2. So for 0 to 6, find both the time and the position of the particle when the particle is furthest to the left. Justify your answer. So in order to figure out when the particle is furthest to the left, we need to determine what its position is at critical times. Now, if you look at the graph, the velocity is negative from 0 to 3, which means it's moving to the left from 0 to 3. So at 3, it could be furthest to the left, but it also changes from negative to positive there, meaning you would have a relative min. So from 3 to 5, the velocity is positive, and then at 5, the velocity changes to negative again. So potentially, t equals 6 could also be the absolute minimum, which would be when the particle is furthest to the left. So we need to not only find those values, but also justify our answer. Here's how we're going to do this. So for part A, the velocity is less than 0 for 0 to 3 and 5 to 6. And the velocity is also positive between 3 and 5. So the object could be furthest to the left at t equals 3 or t equals 6. And the next step is to actually figure out the position. So we're going to use x of 3 to represent the position of the particle when t equals 3. Now remember, to find the position, you need to take the initial position plus the change in position. So the initial position is negative 2 plus the integral from 0 to 3 of v of t dt. So that's going to be negative 2 minus 8, which is negative 10. We know that this region here has an area of 8, so its change in position, since it's below the t-axis, is counted as 8 units to the left. Then we need to figure out the position when t is 6. Again, we're going to take the initial position plus the integral from 0 to 6 of v of t dt. That's just going to be negative 2 plus the sum of the signed areas. So that first area was 8, this area is 3, and the last area was 2. So the 8 gets counted as negative, and the 2 does as well. So if you add all those up, negative 8 plus 3 minus 2 plus the initial condition of negative 2, you're going to get negative 9. So you could say something to the effect of, therefore, the particle is furthest to the left at time t equals 3, and its position is x of 3 equals negative 10. Now, an important consideration here is the units. There are no units given in the problem. Therefore, you don't need to put any units on your answer. If there were units, you would definitely want to report the units on your answer. Now, part A was worth 3 points. You would get 1 point for identifying t equals 3 as a candidate, 1 point for considering the integral from 0 to 6, and 1 point for the correct conclusion. Let's move on to part B, which says, for how many values of t from 0 to 6 is the particle at negative 8? Explain your reasoning. So we know that the particle starts at negative 2 and then has a minimum when t is 3, and that minimum is negative 10. Since the function is continuous, that means it had to pass from negative 2 all the way down to negative 10, passing through negative 8. Also, we know at t equals 5, you have a relative max. If we figure out the position there, we can determine if it increased back up through negative 8. Also, we know that the position at 6 is negative 9, which implies that if the function had passed back up past negative 8, then back down to negative 9 would make a third time, it would have to have passed through negative 8. So this is a classic case of using the intermediate value theorem. To use the intermediate value theorem, you only need the condition that the function is continuous on the interval. Since v is differentiable, we know that v is continuous. So we could say something like from t equals 0 to t equals 3, x is decreasing from x equals -2 to x equals -10. And then we'll go from t equals 3 to t equals 5 and figure out the position. And then from t equals 5 to t equals 6, x is decreasing again, and it decreases from -7 to -9. Then you make your conclusion. By the intermediate value theorem, there are 3 values of t for which the particle is at x equals -8. So for this one, you get 3 points again. You get 1 point for the correct positions at t equals 3, 5, and 6. You get 1 point for describing the motion, like we did here, and 1 point for the correct conclusion. Now, part C, on the interval 2 to 3, is the speed of the particle increasing or decreasing? Now, this one's a little bit more simple than it may sound. Remember, if the speed is increasing, then velocity and acceleration have the same sign. And if speed's decreasing, velocity and acceleration are going to have the opposite signs. So if you look on the interval from 2 to 3, so from here to here, so this portion of the graph, the velocity function itself is negative and increasing. So that would imply that the velocity is negative and acceleration is positive. So they have opposite signs. Therefore, the speed is decreasing. You could say something to the effect of the speed is decreasing on the interval 2 to 3 since velocity is negative and increasing on this interval. Now, you could mention acceleration instead of saying v is increasing by saying something like v prime equals a is greater than 0. You could put that in place of this sentence right there. Either way would be fine. This response was worth 1 point if you have the correct answer and the correct reason. So just 1 point for that one. And lastly, part D, during what time interval, if any, is the acceleration of the particle negative? Justify your answer. Well, this again connects velocity and acceleration. Since we know that acceleration is the derivative of the velocity function, it's going to show up as the slope. So we can interpret this question as saying, when is the slope of the velocity graph negative? Now we know it's decreasing here, so its slope would be negative, and we know it's decreasing here, so we know its slope is negative. Also, in the information, it told us there were horizontal tangents at t equals 1 and t equals 4. So we know from 0 to 1, the velocity is decreasing, and from 4 to 6, the velocity is decreasing. So you could say something as simple as the acceleration is negative on those two intervals since the velocity is decreasing on these intervals. You might even want to add for clarification that v prime equals a. And that's it for this one. This one was worth 2 points. You get a point for the correct answer, and the second point is earned for the correct justification. So here we have our second free response question, and in this one, we are allowed to use Desmos. So we'll bring that in and incorporate it as necessary. Let me read through it for you. Concert tickets went on sale at noon, which is t equals 0, and were sold out within 9 hours. The number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable function L for 0 to 9. Values of L at various times are shown in the table above. So a couple things to note, there are units. It says the function L is twice differentiable. That's going to come up later. And we have t values in the table where t equals 0 corresponds to noon. So part A, we want to use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30, which is t equals 5.5. Show the computations that lead to your answer. We want to make sure we're using correct notation. This would be L prime of 5.5. And since we're estimating the rate, we're going to use the wavy equals signs. And since all we have are data values in the table, we would pick the two values closest to 5.5, which are when t is 4 and 7. So, and we just get the rate of change between those two. So 150 minus 126 over 7 minus 4, which is equal to 8. Make sure you include the units on here, which would be people per hour. And we know that because L is people, T is hours, and we basically did the change in L over the change in T, so it's people per hour. This is worth 2 points. You get 1 point for the estimation, which is 8, and 1 point for the correct units. Now, part D, you want to use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours the tickets were on sale. One thing with a trapezoidal sum is sometimes it's difficult to remember that formula, especially when the subintervals are not all uniform. So another way to understand how to get the trapezoidal sum is it's actually just the average of the left and right endpoint methods. So if you think about it like that, you can simplify what you have to remember in terms of formulas and processes. I would recommend setting up the integral that this represents. So 1/4 times the integral from 0 to 4 of L of t dt, and that's going to be 1/4 times, we're going to do the left endpoint method plus the right endpoint method divided by 2. The left endpoint method, the first subinterval goes from 0 to 1. It's 1 unit wide, and the left endpoint is 120. The next subinterval goes from 1 to 3. It's 2 units wide, and the left endpoint is 156. And the third subinterval goes from 3 to 4. It's 1 unit wide, and the left endpoint is 176. So we have all that. That's the left endpoint method plus, now we're going to do the right endpoint method. Same intervals. So from 0 to 1 is 1 unit wide, but the right endpoint is 156. Then the next one's 2 units wide, the right endpoint 176. And then the last is 1 unit wide, right endpoint is 126. Now you could use Desmos to add this all up and calculate the final value, but you would get 155.25, and the units would be people. Now, real quick, just to show you how the units work out, L of t is people, dt is hours, but 1/4, this 4 comes from the width of the interval from 0 to 4, which is 0 to 4 hours. So it's people times hours divided by hours. So it's 155.25 people. So you would get 1 point for writing out this sum and 1 point for your final answer. Let's move on to part C. For 0 to 9, what is the fewest number of times at which L prime must equal 0? Give a reason for your answer. This is where the idea that the function is twice differentiable is going to come into play. L prime is going to be equal to 0 anytime the original function changes from decreasing to increasing or increasing to decreasing. So if you look at the values in the table, it goes 120, 156, so that's increasing, 176, that's increasing, and then back down to 126. So increase, increase, decrease. So I know somewhere between 3 and 4, there was a change in direction at least once. And then from 126 to 150, it increased there. And then from 150 to 80, it decreased and then decreased to 0. So that implies that there are at least 3 times that L prime must be equal to 0. Now we need to give a reason for our answer here. Use the fact function's twice differentiable and the extreme value theorem. We know that L is continuous on the interval from 1 to 4. We also know the function is continuous on the closed interval from 1 to 4. The extreme value theorem would imply that L is going to attain a max value there. But if you look at L of 3, it's both greater than L of 4, and L of 3 is greater than L of 1. In other words, 176 is bigger than both 156 and 126. So this means that there has to be a relative max in between 1 and 4. 1 and 4 could not be the absolute max since L of 3 is greater than both of those. Also, since L is differentiable, that means that L prime has to equal 0 at some point on that interval. Also, we could apply that same reasoning on the interval 3 to 7 with the relative min for L. L of 4 is less than L of 3 and L of 7. So there has to be a relative min on that interval. And since 126 is lower than both the endpoints, we know it has to occur between 3 and 7. Therefore, since L is differentiable, L prime equals 0 for some value there. And finally, L of 7 is 150, which is greater than the value before it, 126, and the value after it, 80. By that same reasoning, there has to be a relative max somewhere between t equals 4 and t equals 8. Again, since L is differentiable, this means that L prime is going to equal 0. So this gives us at least 3 times that L prime equals 0 on this interval. Now, the question is, how do you say all of that in a concise, clear manner? You could say something to the effect of L is continuous on the closed interval 1 to 4, so L is going to attain a maximum value there. Since L of 3 is greater than L of 1 and L of 4, that max has to occur in between 1 and 4 on the open interval 1 to 4. Similarly, L is going to attain a minimum on 3 to 7 and a max on 4 to 8. Since L is differentiable, L prime has to equal 0 at each extreme point on the interval 0 to 9. So L prime equals 0 for at least 3 values of t in the interval 0 to 9. Part C, you would get 3 points. You get 1 point for considering the relative extrema of L on the interval 0 to 9, 1 point for the analysis, and 1 point for the correct conclusion. Let's move on to Part D. Part D, the rate at which tickets were sold from 0 to 9 is modeled by R equals 550 t e to the negative t over 2 tickets per hour. Based on the model, how many tickets were sold by 3 p.m., t equals 3, to the nearest whole number? So for this one, we need to get the total tickets sold, and we're given the rate function. So in general, when you have a rate and you're asked for the net change, you integrate the rate. So first thing, we're going to write down the notation, which would be the integral from 0 to 3 of r of t dt. And remember, you don't have to copy the function down again inside the integral because it's already named r of t. So it's understood that r of t refers to that function. So this is where Desmos is going to come in. We'll evaluate this integral in Desmos and then write the answer here. Here we are in Desmos. I've already typed in the function for r of t, so we're simply going to use the definite integral. So I and t brings up the integral symbol. You go from 0 up to 3, and then you put r of t dt, and it gives us our answer. So we're going to just write 972.784 on our paper. And you don't need to show anything else because with Desmos, you're allowed to evaluate a definite integral as long as you write down the correct notation here for the definite integral and the correct answer. Now, remember, they said to round it to the nearest whole number. So this is approximately 973 tickets. And if you're wondering how the units work out, R of t is tickets per hour. Right here, they told us. And then dt stands for change in hours. So tickets per hour times hours, you get tickets. Now you could write a sentence saying there were approximately 973 tickets sold by 3 p.m. And there you go. You get 2 points for this one, 1 point for the correct definite integral, and 1 point for the correct answer. Make sure you include your units. General rule of thumb, if the problem has units, make sure you put units on your answer. All right, so this is our last free response question before we jump into some multiple choice. Here we're allowed to use Desmos again, and this is a classic example of a problem in which you have to use area and volume of regions and integrals. So let R be the region bounded by the graphs of y equals sine pi x and y equals x cubed minus 4x, shown in the figure above. Part A, we want to find the area of R. First thing you want to do is show how you found the intersection points of the region. Now, on the graph, it's pretty apparent that they're 0 and 2, but just in case, you want to show the equation that you would solve, which would just be setting the two equations equal to one another. And then right under that, you could put x equals 0, x equals 2. Now, we need to figure out which graph is on top and which one's on bottom. Since we're allowed to use Desmos, to be sure, we're just going to graph the functions. Now, remember, we're only going on the interval 0 to 2, so right here. And I can see that the green graph is on top, which is the sine function. Also, notice I labeled them f and g. That makes it a lot easier to enter the integral. If I want to get the area of the region from 0 to 2, I would just type in 0 to 2, and then in parentheses, do the green function minus the purple function. So f of x minus g of x, and then that's going to equal 4. When you write your answer, you just have to remember to write the functions here instead of f and g. So area equals integral from 0 to 2 of sine pi x minus, now it's important to put the x cubed minus 4x in parentheses because you're subtracting that whole function. And you could write equals 4. And then that's it. For this one, you get 1 point for solving the equations with the correct limit, 1 point for the correct integrand, and 1 point for the correct answer. The horizontal line y equals -2 splits the region R into two parts, right? But do not evaluate an integral expression for the area of the part of R that is below this horizontal line. So if you would imagine a horizontal line right here, we just want the integral that represents that area, but we don't have to actually evaluate it. That means we need to find the intersection point of where x to the third minus 4x equals -2. Just find this out on Desmos. I'll graph y equals -2. And since I'm only concerned with the area of the region below this, I'm going to get these two intersection points here. I can export both of those quickly to my table and just make sure I understand to use the x values here. At the same time, I'm going to evaluate the integral. So I'll go from the first x value. Now, for the limits on paper, you need those to be accurate to at least 3 decimal places. But then if you're using them to get the value of the integral, you want to go out more than 3 decimal places so that there aren't any rounding errors in your final answer for the integral. So I always use as many that I can. Now for the integrand, if we're just getting area, it's going to be the top curve, which is -2, minus the bottom curve, which is g of x, and then dx. Now remember, you didn't have to evaluate this, but I was showing you here how to set up the integral. Now we got a couple of things here. First, we got the intersection points. I'm going to call the first intersection point A. So x equals A equals 0.53919. And x equals B 1.67513. The reason I'm doing this is because whenever you copy the numbers a lot, you may run into some errors. So I can write the area, the integral from A to B of -2 minus the quantity x cubed minus 4x dx. Now you get 1 point for the correct limits and 1 point for the correct integrand. Remember, you did not have to actually evaluate this one, even though Desmos quickly and easily gave us the answer. Moving on to part C, the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Find the volume of this solid. What you have to imagine is a vertical slice perpendicular to the x-axis and then a square. The area function for a square is the side length squared. In this case, this distance right here is the side length of that square. And that again is just top minus bottom. The top curve is sine. This is going to be sine pi x minus the quantity x cubed minus 4x. That whole entire difference squared. And then the volume is just the integral of that from 0 to 2 of the quantity sine pi x minus the quantity x cubed minus 4x all squared dx. And we just go over to Desmos and plug it in. We have our two functions and then the integral is the integral from 0 to 2. And in this case, it's going to be f of x minus g of x quantity squared, because it's the area formula for a square. Now, a common mistake students would make is accidentally putting a pi in here because you're used to the volume formula for a region rotated about an axis, which is pi r squared. So just be careful there. And then you have your answer. Rounded to 3 decimal places, that's 9.978. And there you go. You would get just 2 points for this one. 1 point earned for the integrand and 1 point for the correct answer. Now, part D, the region R models the surface of a small pond. At all points in R at a distance x from the y-axis, the depth of the water is given by h of x equals 3 minus x. Find the volume of the water in the pond. So this is a little bit tricky, but if you imagine this region is the top of the pond, if you take a cross section, just a slice at the top of the pond, then the depth of the pond is equal to 3 minus x. So if you think about that slice as being a rectangle, that rectangle has a base, which is the distance between the two regions. So base would just be sine pi x minus the quantity x cubed minus 4x. Then the height of that region is just 3 minus x. So the area of a cross section is going to be base times height. And then to get the volume, we would just integrate from 0 to 2 the area function with respect to x. So that's just describing it for you guys. Now, I'm going to actually write it out. So the volume is equal to the integral from 0 to 2 of sine pi x minus the quantity x to the third minus 4x times 3 minus x, or you could just write times h of x dx. Then we just go over to Desmos, pump it in, and write down our answer. So this was integral from 0 to 2 of f of x minus g of x times h of x, which was 3 minus x, and then all of that dx. So you would have 8.369, or if you round 8.370, either one is going to be fine, and you would just write that as your answer. Now, again, you get 2 points, 1 point for the correct integrand and 1 point for the correct answer. All right, guys, that's our free response. Let's jump into some multiple choice questions. First one, no calculator of a function given by f equals x cubed has an average value of 9 on the closed interval 0 to k, then k equals, well, average value is 1 over b minus a times the integral from a to b, so 0 to k, of f of x. And they told you that should be equal to 9. So this is going to be 1 over k times 1/4 x to the 4th evaluated from 0 to k equal 9. Now I'm going to multiply the k to the other side. So this is going to be 9k. And then the left side, I'm going to evaluate 1/4 x to the 4th at k and at 0 and subtract. So that's going to be 1/4 k to the 4th, technically minus 1/4 0 to the 4th, which is just 0. Multiply both sides by 4. You have k to the 4th equals 36k. Divide by k. K cubed equals 36. And then take the cube root. You would have 36 to the 1/3. Remember, the cube root is equal to the 1/3 power. Sometimes students forget that. All right, next one. Here we have a Desmos permitted question. A particle moves along the x-axis so that at any time t greater than 0, its velocity is given by v of t, which is that mess there. The total distance traveled by the particle from 0 to 2 is, well, this isn't free response, but I'm going to show you in notation what you would want. Total distance is equal to the integral from 0 to 2 of the absolute value of v of t dt. And then we can pump this into Desmos and get our decimal answer and just fill in the correct choice. We already got our function in there, so we're just going to do our integral for total distance. So integral from 0 to 2 of the absolute value of v of t. Don't forget the absolute values. That's critical. If you end up with a negative answer, you know you did something wrong there. So 1.540 is our answer. And that's going to be choice C. Another Desmos permitted question here. Oil is leaking from a tanker at the rate of capital R gallons per hour, where T is measured in hours. How much oil leaks out of the tanker from 0 to 10? Well, We know the rate. We want to get the total change. You integrate the rate over that interval. So this is just going to be set up as 0 to 10, integral from 0 to 10 of capital R of t dt. And all the units are gallons, so that doesn't help us eliminate any choices, and none of them are negative, so that doesn't help us at all either. So let's hop over to Desmos and calculate this integral. So we have our rate function in there, capital R, and then we just type integral from 0 to 10, capital R of t dt. We have roughly 8,647, which was one of the choices, so that's our answer. So we got choice D here. All right, we're crushing these. This one, you're not permitted, Desmos. The city's built around a circular lake that has a radius of 1 mile. The population density of the city is F of R, people per square mile, where R is the distance from the center of the lake in miles. Which of the following expressions gives the number of people who live within 1 mile of the lake? This one really threw me for a loop at first, but you have to remember, you can always draw a picture. So this is the lake, and it has a radius of 1 mile. Now, the city's built around that lake, and the population density of the city is F of R, people per mile. We also want to know what is the number of people that live within 1 mile of the lake. This is 1 mile as well. Now, R is, in general, the radius of the circle from the lake. We know there's not going to be any people on the lake. So we know we're starting 1 mile from the center of the circle. And then we want to go another mile, which would be 2 miles from the center of the circle for the population. So that means we can already eliminate choice A, choice B, and choice C. So the only choices that are left are very similar, except one has the 1 plus inside of it and the other one doesn't. Well, all we need is the population density function times R. We don't need the plus 1 there because we're not adding 1 to the population density. The 1 comes in because we're moving 1 mile out from the center of the circle all the way to a mile away from the lake. So that's what the limits on the integral are taking care of. Choice E is eliminated, and the correct answer is choice D. Here's our next one. Let R be the region bounded by the graph of x equals e to the y, the vertical line x equals 10, and the horizontal lines y equals 1 and y equals 2, which of the following gives the area of R? This is where having a little bit of understanding of graphs comes into play. So if I have the vertical line x equals 10, and x equals e to the y. If x equals e to the y, then that means that y equals natural log x. Lots of times people know the graph of natural log x and e to the x, but when you have e to the y, things get a little bit weird there. So I know that it crosses at x equals 1, and it's equal to 1 at x equals e. So the graph of natural log is going to kind of look like this. And then we also have the horizontal lines y equals 1 and y equals 2. So we have that horizontal line and this horizontal line. And we want the area of this region. It's hard to determine whether or not that little triangle piece up there is included or not, because I don't know exactly where the intersection point between natural log of x and 10 is. But I know that if I integrate with respect to y, I only have the right and left boundaries. I have the right boundary of 10 and the left boundary of natural log x, or e to the y. So I'm going to pick this one, which is the integral from 1 to 2 of 10 minus e to the y. The integral's limits need to be in terms of y, also dy. So 1 to 2 is what's good here. So S is the region enclosed by the graphs of y equals 2x and y equals 2x squared for 0 to 1. What is the volume of the solid generated when S is revolved about the line y equals 3? It's very helpful to have some understanding of graphs. So y equals 2x is going to be a diagonal line, and 2x squared is going to be an upward opening parabola. Solving these for one another, you would have x squared minus x equals 0. So you would have x at 0 and 1, which confirms the interval here. So you might be tempted to eliminate d and e because those limits are different, but notice those limits are in terms of y. So that's possibility that this problem could be in terms of y. If you imagine the line y equals 3, and you're going to rotate this, in order to rotate it around that, you would need a vertical slice. and then you rotate that around and you get a washer. That right there is why we can eliminate D and E, because those are in terms of y, not x. All the other ones have the same limit, the same pi out front. Since it's a washer, I know my volume formula is going to be the integral of big R squared minus little r squared. Now, the outer radius is the distance from the axis of rotation, which is 3, and the curve that makes the outer radius of the washer, which would be the parabola 2x squared. Little r is the distance from the axis of rotation to the inner radius, which is made by 2x. So you have to be careful here. It's not going to be c. If you look, very, very similar with the squares. So you want big R squared, which is 3 minus 2x squared, and little r squared, which is 3 minus 2x quantity squared. It's going to be choice A. All right, let's keep going here. So for this one, no calculators. Again, the graphs of the function g and the line y equal x are shown in the figure above. The graphs intersect at 0, 0, 1, 1, 2, 2. Which of the following expressions give the area enclosed by the graph? Well, if you notice, you want this region and this region. The top boundary switches at 1, 1. So it's going to be g minus x from 0 to 1, and then x minus g from 1 to 2. So choice 3 works. Choice 1 is going to take the absolute value of the integral of x minus g. This is not going to give you the correct answer, because if you go from 0 to 2 and you do x minus g and you integrate that, well, this region would be positive and this region would be negative, and they would cancel each other out. And then you take the absolute value of that, it would be 0. So it's not 1. This one, however, you're taking the absolute value of the difference between the top and bottom first, and then integrating it. This one's going to work also. So it's choice 2 and 3 only. So choice D. All right, another calculator allowed one. Let R be the region in the first quadrant bound by the curve y equals e to the x squared, the x and y axes, and the vertical line x equals 2. What is the volume of the solid generated when R is revolved about the x-axis? So graph the region here, and it might look a little tricky because there's this gap here. But you have to remember that the region is enclosed by the graph of e to the x squared, the line x equals 2, and the coordinate axes. So it's this section right here, and you would have to go up pretty far to see where e to the x intersects x equals 2. But what I would do is take a vertical strip and rotate that around the x-axis. That's just going to be pi r squared, where the radius is equal to e to the x squared. The volume is going to be pi times the integral from 0 to 2 of e to the x squared, quantity squared, dx. Now you could just double check this by doing pi integral from 0 to 2 of f of x squared. I'll put my other parenthesis on there. Yeah, so you get the same thing there. So 1,266.125. And that's going to give us choice D. Let R be the region in the first quadrant bounded by the graph of y equals root x minus 1, the x-axis, and the vertical line x equals 10. Which of the following integrals gives the volume of the solid generated by revolving R about the y-axis? So if we look at our region, square root x minus 1 is the square root graph shifted 1 unit to the right. So it's like this. Then x equals 10. It's going to be there. This point right here would just be 3. And we want this region, and we're going to rotate it about the y-axis. So our strip needs to be perpendicular to the axis of rotation, so it's going to be a horizontal strip. I know if it's a horizontal strip, it has to be with respect to y, so I can eliminate those two. Now I have to solve y equals square root x minus 1 for x. So that's going to be y squared plus 1 equals x. So a typical cross section rotated around is going to give me a washer. So the volume formula is going to be big R squared minus little r squared dy in this case. Big R is going to be right minus left in the distance from the axis of rotation to the outside radius. Well, the outside radius is made by 10, so it's going to be 10 minus technically 0, and then you square that for the r squared, and you would get 100. Little r is going to be the distance from the axis of rotation to the inner circle, which is made by the graph of x equals y squared plus 1. So if you do right minus left, you have y squared plus 1 minus 0 technically, and r squared would be that quantity squared. So this ends up giving us choice B. All right, that's it for that one. All right, guys, that wraps it up for Unit 8 multiple choice and free response questions. Hope that was helpful to you. And make sure you subscribe. I'll be releasing more videos reviewing for the AP exam. And check out my channel as well. I have tons and tons of review walkthroughs there. Take care.